Metamodel or surrogate model is a model of a model, and metamodeling is the process of generating such metamodels. Metamodeling or metamodeling is the analysis, construction and development of the frames, rules, constraints, models and theories applicable and useful for modeling a predefined class of problems. As its name implies, this concept applies the notions of meta and modeling in software engineering and systems engineering. Metamodels are of many types and have diverse applications. Overview: a metamodel or surrogate model is a model of a model, that is a simplified model of an actual model of a circuit, system, or software-like entity. Metamodel can be a mathematical relation or algorithm representing input and output relations. A model is an abstraction of phenomena in the real world. A metamodel is yet another abstraction, highlighting properties of the model itself. A model conforms to its metamodel in the way that a computer program conforms to the grammar of the programming language in which it is written. Various types of metamodels include polynomial equations, neural network, Kriging, etc. Metamodeling is the construction of a collection of concepts within a certain domain. Metamodeling typically involves studying the output and input relationships and then fitting right metamodels to represent that behavior. Common uses for metamodels are, as a schema for semantic data that needs to be exchanged or stored, as a language that supports a particular method or process, as a language to express additional semantics of existing information, as a mechanism to create tools that work with a broad class of models at runtime, as a schema for modeling and automatically exploring sentences of a language with applications to automated test synthesis. Because of the meta character of metamodeling, both the praxis and theory of metamodels are of relevance to meta-science, meta-philosophy, meta-theories and systemics, and meta-consciousness. The concept can be useful in mathematics, and has practical applications in computer science and computer engineering software engineering. The latter are the main focus of this article. Metamodeling topics. Definition: in software engineering, the use of models is more and more recommended. This should be contrasted with the classical code-based development techniques. A model always conforms to a unique metamodel. One of the currently most active branch of model-driven engineering is the approach named model-driven architecture proposed by OMG. This approach is based on the utilization of a language to write metamodels called the Meta-Object Facility or MOF. Typical metamodels proposed by OMG are UML, SYSML, SPEM or CWM. ISO has also published the standard metamodel ISO IEC 24744. All the languages presented below could be defined as MOF metamodels. Metadata modeling. Metadata modeling is a type of metamodeling used in software engineering and systems engineering for the analysis and construction of models applicable and useful to some predefined class of problems. Model transformations. One important move in model-driven engineering is the systematic use of model transformation languages. The OMG has proposed a standard for this called QVT for queries transformations. QVT is based on the Meta-Object Facility or MOF. Among many other model transformation languages, some examples of implementations of this standard are Andro MDA, Vitra, TFCAT, MT, many designs Portofino. Relationship to ontologies. Metamodels are closely related to ontologies. Both are often used to describe and analyze the relations between concepts. Ontologies express something meaningful within a specified universe or domain of discourse by utilizing a grammar for using vocabulary. The grammar specifies what it means to be a well-formed statement, assertion, query, etc. on how terms in the ontologia unregistered trademark S-controlled vocabulary can be used together. Meta-modeling can be considered as an explicit description of how a domain-specific model is built. In particular, this comprises a formalized specification of the domain-specific notations. Typically, metamodels are and always should follow, a strict rule set. A OEA valid metamodel is an ontology, but not all ontologies are modeled explicitly as metamodels. Types of metamodels. For software engineering, Several types of models can be distinguished: metadata modeling, meter process modeling, executable meter modeling, model transformation language, polynomial metamodels, neural network metamodels, Kriging metamodels, piecewise polynomial metamodels, zoos of metamodels. A library of similar metamodels has been called a zoo of metamodels. There are several types of metamodel zoos. Some are expressed in ECL. Others are written in MOF 1.4, XMI 1.2. The metamodels expressed in UML XMI 1.2 may be uploaded in Poseidon for UML, a UML case tool. See also, Business Reference Model, Data Governance, Model-Driven Engineering, Model-Driven Architecture, Domain-Specific Language, Domain-Specific Modeling, Generic Eclipse Modeling System, KERMeter, Metadata, Meter Case Tool, Method Engineering, MODAF Meter Model, MOF Queries Transformations, Object Process Methodology, Requirements Analysis, Surrogate Model, Transformation Language, Vitra, XML Transformation Language, References. Further reading, J. Bazivin, On the Unification Power of Models, in Software and System Modeling 4, 2, 171 188. Booch, G., Rumbaugh, J., Jacobson, I., The Unified Modeling Language User Guide, Redwood City, California, Addison Wesley Longman Publishing Company, Incorporated. J. P. Van Gigch, System Design Modeling and Metamodeling, Plenum Press, New York, 1991, Gopi Balasu, Humara In, 2004 Model-Driven Transformation, P.C. Smolik, Mumbo Metamodeling Environment, Doctoral Thesis, GNU University of Technology 2006, Gonzalez Perez, C&B Henderson Sellers, 2008. Metamodeling for Software Engineering. Chichester, Wiley. 210 ISBN 978-0-470-03036-3, M. A. Juicefeld, M. Eck, and J. Malopoulos, 2009. Metamodeling for Method Engineering. Cambridge, The MIT Press. 424 ISBN 978-0-262-10108-0, G. Caplet Modelay and Mar. Copyright to Modelay, 2008, ISBN 978-2-88074-749-7, Phil, H. G., Karadianis, D., 2013. On the Conceptualization of Modeling Methods Using the ADUGS Meter Modeling Platform, Enterprise Modeling and Information Systems Architectures, Volume 8, Issue 1, 4-25.